Hello students, and welcome to our lesson on arithmetic sequences. We're going to be doing this lesson today to set up what is the rest of the class, all about graphing linear functions, linear equations. And this one is going to explain to us why a line goes up by the same amount every time. So the most important takeaway from this lesson is going to be the idea of a common difference, which is eventually going to be called slope later in this class. So with that said, let's go ahead and get straight into it with what is a sequence. So a sequence, you might have heard the term before. A sequence is an ordered list of numbers that follow a specific pattern. So for example, if I say 1, 2, 3, 4 with a dot, dot, dot at the end, saying that that keeps going, that is a sequence where I'm going up by 1 each time. So the pattern is that you go up by 1. Okay. Each number in a sequence is called a term. So we will have several terms in our sequence. And in order to label these terms, we use subscripts. So now we don't have to use the letter A, but A is what's going to be used throughout this course. In other contexts, they might use a different letter, but in this case, A is the name of our sequence. So this is sequence A. And then we use these subscripts to denote which term in the sequence we're talking about. We start with A naught, okay? A sub 0 is called A naught. That is going to be our initial or first term. And then we just add 1 to the subscript each time. So then we have A1, A2, A3, and that will go on for forever. So our first couple examples down here, we're just going to practice labeling what the terms are real quick. That way we're all on the same page. So for number 1, we have the terms 4, 7, 10, 13. We are not trying to say anything about the sequence. We're just labeling the terms here. So if I go in here, 4 is going to be A naught because that is our first term. 7 is A sub 1. 10 is A sub 2. And 13 is A sub 3. Okay. It'll often be called just A0, A1, A2, A3 because that's more convenient than saying the word sub in between every time. But technically speaking, we have that the initial term, that A sub 0, is called A naught, okay, where I think of it as KNOT, although I'm not actually sure how you're supposed to spell that naught. So we have A naught, and then A sub 1, A sub 2, A sub 3. So I'll label the third one there is A sub 3. Okay, just so we're clear as I'm talking through these things. All right, number 2, we have 20, 15, 10, 5. So 20 would be our A naught, 15 would be our A sub 1, 10 would be our A sub 2, and 5 is our A sub 3. All right, so that's just the very basics. Now let's get into what these arithmetic sequences are all about. So specifically above, we were just saying sequence. Now I'm adding this extra word in front, this word arithmetic. Okay, in an arithmetic sequence, your brain should go to arithmetic. Okay, arithmetic, arithmetic. Okay, in an arithmetic sequence, each term, A sub n, is found by adding the same value, which we will call d, to the previous term. And if we're on A sub n, then the previous term would be A sub n minus 1. Let me write that just slightly lower so we can actually read the A sub n minus 1. I'll put it below the line. Okay, so the key to an arithmetic sequence is that we add the same amount each time. So we end up with this formula here that A sub n is equal to A sub n minus 1 plus d. Okay, so what this means is that if you have a term, A sub n minus 1, and you add d, it takes you to the next term. So all we have to do to go from one term to the next is add whatever this d value is every time. So now I'm tired of saying the letter d. So instead, let's give it a name. D is referred to as the common difference. Okay, it's the common difference because it is the difference between terms. And well, why do I know it's the difference between terms? Well, notice that that formula in the middle there, which is called the recursive formula, above can be solved for d to show that. So if I real quick subtract a sub n minus 1 from both sides, we'd get a sub n minus a sub n minus 1 is equal to d. So that means that d is equal to exactly what we have there, a sub n minus a sub n minus 1. So now how does that connect? Well, we learned in this class that the word difference in math means to subtract. right? So if we subtract two terms that are next to each other, we are finding the difference of those two terms. And what's special about an arithmetic sequence is that no matter which two terms you subtract, as long as they're next to each other, you're going to get that same value for D. So whenever you get the same thing over and over again, we call that being common. All right, so a common difference is subtraction of terms, the difference of terms that is the same for every set of two terms. So now we also have this word recursive here. We're going to have an explicit formula on the next page, but for this one, we call this a recursive formula because the way this formula up here works is that it gives you only the next term. So if you have a term, the recursive formula gives you that very next term. It does not, however, give you a term way in the future. You have to go one term at a time in order to get there. And we're going to talk more about that on the next page. So first, we have some examples down here where we're going to find the common difference for each sequence, and then we will use that to find the next two terms, a sub 4 and a sub 5. So now, this is going to be really easy once we get going. So I'm going to do the first two, and then I encourage you to pause the video and really try the next four by yourself, because once you see me do one or two, you should be able to get the hang of this. So number 3 down here, we have the terms 4, 7, 10, 13. So all I have to do is subtract two consecutive terms. So to go from 4 to 7, I know that that is me adding 3 each time. But in case it's ever not clear what that number is, so like some of the later examples are decimals and fractions, it's a little less clear. What you're going to do is take a term, so the second term is 7, and subtract the first term, so the term before it. And when you do 7 minus 4, that gives me 3, so 3 is my common difference. So I can go ahead here and say that D is equal to 3, common difference is 3. And then all I have to do now is use this D value to get the next two terms. So notice that when I went from 4 to 7, I added 3. And then you add 3 again to go from 7 to 10, add 3 again to go from 10 to 13. And if I want to keep going, I just keep adding 3 each time. So the way I can get to the next two terms is 13 plus 3 gives me 16, and 16 plus 3 is going to give me 19. So now just making sure we're using our proper labels, a sub 4 is the 16, and a sub 5 is the 19. All right, so that formula up above, I don't really need to use it in terms of writing it down explicitly. I just need to understand what it's telling me is that in order to go from one term to the next term, you add the common difference. So that's all this formula says, is to go from a term to the next term, you just add D to get there. All right, number 4, we have 20, 15, 10, 5. If I subtract consecutive terms, 15 minus 20 gives me negative 5. So that means each time I go from one term to the next, I am subtracting 5. And you can double check by checking the next couple. 15 minus 5 gives you 10. 10 minus 5 gives you 5. So this is working, okay? Our common difference is that negative 5. And so now if I want to get the next term in the sequence, a sub 4, all I do is subtract 5 again. So a sub 4 is going to be equal to 5 minus 5, which gives me 0. And then to get the term after that, I subtract 5 again to get negative 5. For number 5 here, and by the way, if you haven't yet, I encourage you, pause the video, try these for yourself before I give you all the answers here. For number 5, we're going from negative 3 to negative 1 to 1 to 3. I encourage you to, at first, just look at it and see if it's easy to tell that we are adding 2 each time. But if that is ever not obvious for you, on the side, take the second term, which is negative 1, and subtract the first term, which is negative 3. Notice, because I'm subtracting a negative, I put the negative sign in parentheses, so it's negative 1 minus negative 3, which really means negative 1 plus 3, so that equals positive 2. So my common difference is positive 2. I can double check that by doing negative 1 plus 2 gives me positive 1. Positive 1 plus 2 gives me positive 3, so this is definitely working. So I can just go ahead here and say D is equal to 2. And then now we need to find the next two terms by just continuing to add 2. So a sub 4 is going to be equal to 3 plus 2, which is 5. And a sub 5 is going to be equal to 5 plus 2, which is 7. All right, now we're going to make it a little bit harder just by making the numbers a little less convenient looking. So number 6, our terms are 1/2, 1, 3 over 2 and 2. So we just need to choose two terms and do the subtraction. So I'm going to take the second term, which is 1, and subtract the first term, which is 1/2. 1 minus 1/2, I need a common denominator in order to do that. So this is the same thing as 2 over 2 minus 1/2, which is just 1/2. Right, so my common difference here is positive 1/2, and you can double check that that works on the next couple, which it does. So d equals 1/2. So now to find a sub 4, all I have to do is take my last term, which is 2, and add 1/2 to it. So when I do 2 plus 1/2, I can either write my answer here as 2 and 1/2 as a mixed number, that's okay, or 2 and 1/2 as a fraction is going to be 5 over 2. Okay, so 2 and 1/2 or 5 over 2. And then for a sub 5, we're just going to add 1/2 again. 5 over 2 plus 1 over 2 is going to be 6 over 2, and that just reduces to be 3. So just to be clear, I'm going to write those out in a little bit more detail. I got a sub 4 by doing 2 plus 1/2, and 2 plus 1/2 is the same as 4 over 2 plus 1 over 2, so that's 5 over 2. For the one after that, I took 5 over 2, and I added 1/2 again, which gave me 6 over 2, but 6 over 2 reduces to be 3. All right, number 7. We have 5.2, 4.8, 4.4, and 4.0. If I do a little subtraction here, 4.8 minus 5.2, that gives me negative 0.4. So I am subtracting 0.4 each time. So to go from one term to the next, negative 0.4. That means my d value is that 0.4. Oops, sorry, is a negative 0.4. So the common difference is negative 4/10. And now to find the next term, all I have to do is keep subtracting 0.4. So a sub 4, got a little messy there, let me fix that. A sub 4 is going to be equal to 4 minus 0.4, which is 3.6. And a sub 5 is equal to 3.6 minus 0.4, which is 3.2. All right, number 8. This one's a little bit trickier because we have thirds, a little harder to see what's going on here. We have negative 7 over 3, negative 2, negative 5 over 3, and negative 4 over 3. If I do the subtraction on the side, negative 2 minus negative 7 over 3, this is not a super convenient thing to do subtraction for, right? We have a lot of negative signs going around, and we don't have a common denominator. So what I'm going to do is rewrite this in a more convenient form. Negative 2 is really, if I want a denominator of 3, is negative 6 over 3. And because I'm subtracting negative 7/3, that's the same thing as adding 7/3. So this problem that I wrote up above is the same thing as negative 6 over 3 plus 7 over 3, which just equals positive 1 over 3. So in reality, my common difference is just plus 1/3. And if you double check, that is going to work for each consecutive term. So d is equal to positive 1 over 3. And if I want to find a sub 4, all I have to do is take negative 4/3 and add 1/3. Negative 4/3 plus 1/3 is negative 3/3, and negative 3/3 is just negative 1. Okay, then I'm going to subtract 1/3 again, or sorry, add 1/3 again. So negative 1, again, was negative 3 over 3. If I add 1, I get negative 2 over 3. So I end up with a common difference of 1/3, and then a sub 4 is negative 1, and a sub 5 is negative 2 over 3. All right, so now we're going to make it a little harder, a little bit more fun though. Okay, this was the recursive formula, which was great if you need the next term. But what if you want a term that's far away? So the recursive formula does make it easy to find that next term in a sequence, but it is not convenient for finding what I'm going to call specific terms, meaning you want term 73. Okay, that's a very specific term. So what we have instead of the recursive formula is called the explicit formula. Okay, the explicit formula allows us to compute any term directly, where all we need is the initial term, that's a sub 0, and the common difference, which is d. So as long as we have those two things, we can find any term. So now I'm going to prove to you where the explicit formula comes from real quick, and I bet you're going to be able to follow this one. This proof's not too hard. So starting at the top, A naught equals A naught. I think we can all agree that that is true, right? A naught is itself. So then let's go down a row. If I want to find A sub 1, the recursive formula on the last slide told me to take A naught and add D. So right here, this second row, A sub 1 equals A naught plus D, that is how I get to A sub 1 using the recursive formula. So all I did to go from the first one to the second one was do plus D. So now I want to find A sub 2 for the third row here. A sub 2 is equal to A sub 1 plus D again. So all I have to do is add D again to get there. But instead of writing it as A sub 1 plus D, I'm going to leave it as A naught here. But since I already had A naught plus D, and then I'm adding D again, now I have A naught plus 2D. So look at what we just uncovered. A sub 2 is equal to A sub naught plus 2D. Notice A sub 2, 2D. Okay. If I add D again to get to A sub 3, we uncover the fact that A sub 3 is equal to A naught plus 3D. Okay, I had to add that common difference 3 times. So now this gives us our explicit formula. If I want to get to A sub n, all I have to do is take A naught and add D n times. So A sub n is equal to A naught plus nd, where we multiply that d times n. All right, and we are going to be able to use this formula to find any term we want. So check this out for number 9. Number 9 says A naught is 3, D is 6, and we want to find A sub 10. All I'm going to do is take the formula, A sub n equals A naught plus n times D, and plug in my numbers here. So A sub 10 is going to be equal to A naught, which is 3, plus n times D. N here is 10, so 10 times D, and D is 6. So I have that A sub 10 is equal to 3 plus 10 times 6. So what this means is that I had to add 6 10 times to get from A naught to A10, which is exactly what we were doing on the previous slide. Okay, we were just adding D over and over and over again. If I simplify this, we get that A sub 10 is equal to 3 plus 60, so that is just 63. So just like that, I can get to A sub 10 without really knowing any of the terms in between or even having to care about them for that matter. All right, number 10 says to find A sub 20, and we are given the sequence 12, 15, 18, ... So remember that we need the initial term and we need D. So we have the initial term given to us. A sub 0 is that 12 that's in front. So now all we have to do is establish the common difference. In order to go from 12 to 15, I'm just adding 3 each time. And then we can double check 15 to 18, adding 3 each time again. So we have everything we need here to say that A sub 20 is equal to 12, which was our initial term, plus our common difference times 20, because we're looking for term 20. So A sub 20 tells me to put a 20 here and multiply it by that 3. Now, if we just simplify, A sub 20 is equal to 12 plus 60, so that is 72. Now, you could keep adding 3 20 more times to get there, but it is far, far quicker to just multiply 3 by 20 and add it to that initial term. All right, number 11. Now we're going to do the opposite. We're going to find D given that A sub naught is negative 5 and A sub 99 is negative 500. So what we're going to do is set up that same explicit formula, but now we're going to solve for D. So we have that A sub 99 is negative 500. That's going to go on the left. This is supposed to be equal to A naught, which is negative 5, plus n times D. So here n is 99, and then we're multiplying by D. We do not know what D is, so we have to solve this equation. If I add 5 to both sides, okay, remember we're just solving an equation like normal, so no crazy steps here. We're just trying to isolate D. Negative 500 plus 5 is negative 495. The negative 5 and the 5 cancel, so we're just left with 99D. And if we divide both sides by 99, we get our D value Where here, if you're unsure, you can double check with a calculator, but we should end up with negative 495 divided by 99 is negative 5, and this needs to be equal to our d value. So our common difference that takes us from negative 5 all the way to negative 500 is that we just keep subtracting 5 all the way until we get there. All right, now let's put this to a couple applications. Number 12, a nurse starts a new shift with 10 patients and receives 2 new patients each hour. Find how many patients there will be after 6 hours. So first we're going to just draw it out and do this kind of the hard way, so to speak, and then we'll use the formulas to show that we did it correctly. So when the nurse gets there, 10 patients. Okay, so we start with 10. That's our first term of our sequence. Then every hour, the nurse is receiving 2 new patients, and this is going to happen for 6 hours. So after 1 hour, we're at 12 because we just add 2. So that's, just to be clear, after 1 hour, we're at 2. Then we add 2 again. So after 2 hours, we're at 14. After 3 hours, we're at 16. After 4 hours, we're at 18. After 5 hours, we're at 20. And after 6 hours, we're at 22. Okay, so we went from 10 all the way up to 22. So we know that 22 patients is going to be the answer. But let's just real quick think of this in terms of sequence now. Okay, so let's pretend that we didn't want to write it out, or even better, let's pretend that it didn't say after 6 hours, pretend it said after 600 hours. So it would be way too much work to write this all out. So let's think about how many times did we add that common difference. We started with our A naught being 10, and then we added D once, so plus D to get to 12, and then plus D to get to 14, plus D to get to 16, plus D to get to 18, plus D to get to 20, and plus D one more time to get to 22. So how many times did we add D? Well, count them up. 1, 2, 3, 4, 5, 6. We added D 6 times, which should make sense since it's been 6 hours, right? So if we set this up as a sequence, okay, or using our explicit formula, we are looking for how many patients are after 6 hours. Okay, after 6 hours, we got to think, is that A sub 0 or A sub 6 or A sub 7? Like what number subscript do we use here? So real quick, let's use the example we have on the screen. We have that 10 is A sub 0. So 12 is A sub 1, then A sub 2, A sub 3, A sub 4, A sub 5. So 22 is A sub 6. Okay, so we can go ahead and say here that A sub 6 is what we're looking for, the number of patients after 6 hours. And this is going to be equal to A naught, which was 10, plus 6 times our common difference, which is 2. If I do 10 plus 6 times 2, that's just 10 plus 12. So A sub 6 is equal to 22, just like what we had before. So we can then go ahead and say that the nurse has 22 patients after 6 hours. Oh, and I spelled patience as how long you're willing to wait, not the hospital version. So let me fix that. Patience with a T. All right, so we did that one both ways, but I want to point out that I only did it the way on the left, okay, where I actually added D each time to show you where these numbers are coming from. But in reality, we would strongly prefer to jump straight to just using this explicit formula whenever possible. All right, that being said, let's do number 13. Last one here. A subscription costs $5 for the first month, A naught, and increases by $3 each month. Write a formula for the cost in month n, which would be term A sub n minus 1, and find the cost in month 12, which is actually A sub 11. So now before we try to do the problem, I just want to explain like what is happening here with these subscripts. So I'm saying at the end here that month 12 is A sub 11. That might seem wrong that we have to subtract 1, but it's because we start at term 0, okay? A naught, A sub 0. In the previous question, you might be wondering, like we said after 6 hours, and that's A sub 6. So like the numbers are the same, 6 and 6. The reason this is different is the question number 13 says the cost in month 12, not the cost after 12 months. Okay, so after 12 months would mean we're looking for a sub 12. But the cost in month 12 means we've only actually gone 11 months to get there. So similarly in problem 12, when we said after 6 hours, we're asking how many patients the nurse has in hour 7. Okay, hour 7 is the hour we're in if it's been 6 hours. All right, so that's why the subscripts are -1 each time, because when you're in month 12, it's been 11 months. All right, so now it says a subscription costs $5 for the first month. So we know that A naught equals 5. And it increases by $3 each month. So we know that D equals 3. It says to write a formula for the cost in month N, where we are looking for A sub N minus 1. Okay, so we can go ahead and say that A sub N minus 1 is equal to, and we're just going to use the explicit formula. It's A naught, which is 5, plus the number, the index here, N minus 1 times our common difference. So N minus 1 times our common difference, which is 3. So this formula here will give you the cost in month N, which means you are finding A sub N minus 1. So now if we want to use this to find the cost in month 12, we're just finding A sub 11. That's all we're doing. So if I make N equal 12, then I am finding A sub 12 minus 1. Okay, notice that 12 minus 1 is in fact A sub 11. A sub 12 minus 1 is going to be equal to 5 plus 12 minus 1 times 3. And notice what happens when I simplify this, right? We get A sub 11 equals 5 plus 11 times 3. And that's exactly what our explicit formula normally is. Okay, so the only thing that made this feel a little bit awkward is the fact that we do this N minus 1 thing. That way we can properly represent which month we're in. All right, so now the cost in month 12 is just 5 plus 11 times 3. So the cost in month 12 is 5 plus 33, which is $38. So we can go ahead and just summarize here. The cost in month 12, which is A sub 11, is $38. And that is the conclusion of our lesson on arithmetic sequences. I really look forward to you guys joining me for when we connect this to linear equations where we're going to be graphing lines. Because what we're going to do is we're going to take these sequences and turn them into equations using x's and y's. And hopefully when we tie all that together, it's going to make a whole lot of sense for us. All right, see you guys in that next one.